let's start with this. So my first output target is y here, okay? So I'm going to first map my y on this graph here. That's my y0, okay, the first point. So y0 is here, because this is a 45-degree line, right? So y0 can be mapped here. Okay, if the output target is y0, okay, what is the quantity of input required to produce that y0? Is this x0? Okay, x0 is here. Okay, I'm going to project the x0 on this graph here. That's x0. Okay, when x0 is given, the price of the input x is given. What is my variable cost? It's r times x, x0. Correct? That's my variable cost. Okay, now I'm going to project this here to meet my output target. That's one point on my variable cost curve, right? Okay, pick another output target here, y0, y1. Okay, y1 is here. Okay, so find my y1 on this. I'm going to call this 1, 2, 3, 4. Okay, diagram 4 here. That's my y1. Okay. When y1 is given, I can also figure out my variable cost. It's this. So this is x1. Okay. This is x1. And this point is my variable cost, rx1. Okay. And now I can find this point on diagram 4 where rx1 meets y1. Okay, I got 2 points. Find another one here. y2. Okay. Find y2 first on this diagram 4. It's y2. Okay. And find the variable cost. This is r times x2. Okay. So with that, I can map out. Additionally, I have origin here because when I produce nothing, the input requirement is 0. So variable cost is 0. So I have another point here. I can trace out those 4 points to get my variable cost curve. Okay, this is something. Maybe I didn't do this very precisely. So, but, you see the shape of the cost curve. Okay, what this exercise tells us is this cost function, okay, really depends on the shape of the production function. There's a one-to-one correspondence. If you change the shape of the production function, this variable cost function is going to change. Okay? Because the 45-degree line is given. Okay, you cannot change that. This r is taken as given. The rate of this linear line is given. So if you change the production function, the variable cost function is going to change. Okay? This is consistent with the statement we have given earlier, that this cost function, conditional demand function are derived concepts. Depends on the constraint. Remember, when we minimize cost, we have a constraint, which is y is equal to f, x1, x2. Because of that constraint, we have the particular shape of this cost function. And more than that, okay? Look at here. When alpha is a number between 0 and 1, okay? So we see there's a diminished marginal returns. And technically speaking, this production function is concave. Okay? A concave production function corresponds to a convex cost function. I mean convex in terms of y, not in terms of R1 and R2. Okay? So that means what? Look at here, okay? Using kind of English, when I increase, diminish marginal returns when I increase my input level, okay? When I do this kind of successively, the additional y I can produce by increasing my x is going to decline. Okay. On this graph, that means if I want to increase my output, okay, as I do this successively, okay, the additional cost required to produce that y is going to increase. That's because of the law of diminishing marginal returns here. Okay. Does that make sense? Okay, look at here. If you increase 1 unit of y here, okay, but you only need increase a little bit of x. But when you increase a lot of y already, okay, each unit of y requires more input increase here. So the cost will be, additional cost will be higher. Okay. So the shape of the cost function is because of the shape of the production function. Okay? And from this functional form, you can see this. Okay? Look at the cost function. Depends on R, which is given. Okay? Y is given. Okay? Look at here. The other things determine the functional form is A and alpha. Where are these variables from? From the production function. If you change A, this function is going to change. If you change alpha, this function is going to change. Okay? So there's a one-to-one correspondence between the cost function and the production function. This is called the duality. Later on, we'll probably talk more about this. It's a duality between production function and cost function. Okay. So this comes back again. Okay, I want to emphasize this. So if you want to get your effective demand, you can start from a production function. You can get your effective demand. Or you can start with the cost function, get your effective demand. Okay?
So to simplify that, what you're saying is due to diminishing MRS, we have increasing marginal cost.
Increasing marginal cost, yes. So diminishing marginal returns imply increasing marginal cost. Yes. Yeah. So the marginal cost, now we can draw the marginal cost curve here. I'm going to put it here. Okay? Look at here, the marginal cost is the slope of this variable cost, right? It's increasing. So it's going to be this marginal cost. Okay? Which is what we have seen most of the undergraduate course. Marginal cost increasing. Okay? Okay, that's any questions on this marginal cost and variable cost before we move on?
I still have a question on, you call it variable cost. Is the cost function in respect to price and why? Why do you call it variable cost?
Because there's, in this setting, there's some variables factors are fixed. Okay. Going back to the cost minimization problem, let me write it here, okay. Minimize my cost.